Okay, so today this video is going to cover properties of special parallelograms. So in the last video, we talked about things that we know are true for all parallelograms. Today, things that we know for true are just true for certain types of parallelograms. So the first thing I want you to do, we've got a parallelogram here. I want you just to use this as an opportunity to check your understanding and see how you're doing with this stuff. So see if you can find X, Y, and Z in this parallelogram. Pause the video, do those, and then I'll have the answers in just a second, but I want you to try it first. Okay, so hopefully you tried this. Keep in mind the fact that if you haven't tried these until you get to the test or the quiz, it's going to be a lot harder, so try them first. So first thing we might want to do is to find angle Z. That'd probably be where I'd start. And we know that opposite angles in a parallelogram have to be equal. So Z has to be 75 degrees. And so I'll put 75 right in there just so I have it. The next thing I might want to do is find Y. And one thing we know is that if you take those angles there, they have to add up to 180. So if I take 180 minus 75, I get 105. That's this whole angle. Now I know this part's 25, so 105 minus 25 is 80. And so Y has to equal 80 in this case. You could also do this a couple of different ways. If I know this angle is 25, then I also know that this angle is 25, and then I can use this triangle, knowing that that adds up to 180. That would be another way to do it. I'll go ahead and undo that. The last thing we're going to want to do is find X. Now this is a parallelogram, and one of the things we know about parallelograms is that the opposite sides are congruent. The opposite angles are too. So we know that 3x plus 3 has to be equal to 5x minus 7. Now I can start to solve this. Good strategy is to always take care of your x's first. I'm going to get rid of the smaller one so that I don't have to deal with negatives. They cancel out on this side. The 3 is left over. 5x minus 3x is 2x and minus 7. Then I can solve it by adding 7 to both sides. 10 equals 2x. And divide by 2, so x equals 5. So there we go. That's kind of covering the basics of parallelograms. If you can do something like that, then you've got a pretty good understanding of the parallelogram properties that we've discussed. Also, make sure that you've checked your answers. These are posted on the Canvas page, so take a look at those. If you're at home, make sure you are asking about any that you are missing. So today is properties of special parallelograms. We're going to talk about the different kinds of special parallelograms, those being rectangles, rhombuses, and then the most special of all is a square, and what properties they have and how they are classified. So we did this yesterday in the parallelograms video. Remember, a parallelogram has to have parallel sides, and that's pretty much it. That is the definition of a parallelogram. Now, we know about all of the properties of parallelograms. If you need to review those, go back and look at the video from yesterday. All of those properties we talked about yesterday are also true of rectangles, rhombuses, and squares. You kind of will hear this referred to as a family tree often. So you can kind of think of this like parallelograms are the mammals. And then down here, rhombuses are kind of like, what are they called? Primates. And then squares are like humans, right? So us as humans are special types of primates, and all primates are special types of mammals. And so for the most part, sorry, biology teachers, because we are humans, we have in common all the things of all other mammals, in addition to all the things of primates. And then there are some special things that are only true for us. That's kind of the exact same way that this works. It's a very, very similar idea. That's why family tree is kind of a very common way of describing this. So today we're going to take a look at these last couple here. If we were in class again, we'd do a little activity. I suppose I can post the activity if you wanted to do it yourself, but there you go. So here's what we've got. Again, I will post this activity up, so if you want to do it, you can. We've got a grid I would have each of you have made a rectangle on that grid using the lines on the grid. The big thing here is if you're going to do this on your own, don't make a square, because then you're going to find some things that might not be true for all rectangles. And so what I'm asking you to do is to measure the diagonals. And so I'm going to draw them in here. And what I usually have people do is, rather than actually measuring everything, we can use patty paper, tracing paper, to do this. And so if I take a look there, I'm going to, what am I going to do? I'm going to set this so I can allow move and rotate only, but it won't let me change the size. So if I grab that, will it let me rotate it? It doesn't look like it's even going to let me rotate it. Never mind. We'll just measure it. So if I measure one of these, I'm going to go from one corner of my rectangle to the other, and I'm just going to make my ruler a little bit longer so it's a nice number. I know you can't do that in real life, but whatever. So that one is 9 centimeters long going that way. Now I'm going to measure it this way, and you'll notice also 9 centimeters long. So in addition to all of the things that we know about rectangles or parallelogram diagonals, we also know that the diagonals of a rectangle are congruent to each other. That is really nice. That is the first shape that's really been true for, except for isosceles trapezoids.
Lunch students are now dismissed for lunch.
Okay, if you're in C lunch, you go to lunch now. Okay, then we're taking a look at rhombuses. And so rhombuses, we're going to be concerned about their diagonals as well. And so I'm going to draw these in real quick. If you were in class, you'd be doing this. So I draw those diagonals in, and the question is, what do you notice about them? And the question I have here is, are they congruent? Well, definitely not. In this case, this diagonal is way longer than this diagonal. They do bisect each other, but that's true for all parallelograms. And so I've got another question then, is what about the angles where the diagonals meet? So if you were to get out a protractor here, or even just the corner of a piece of paper, I bet you could take a look at this and see what you notice. Let's bring that down. So if I put that right on the vertex there where they meet, and I put this lined up with one side, you will notice that the other one is right there at 90 degrees. So these diagonals are perpendicular to each other. And the same thing you'll notice over there. So the diagonals of a rhombus are perpendicular. That would be another good thing you're going to want to get written down in your conjecture list. I know you don't have I don't have my camera on, sorry. But if you look at tomorrow's day, you're going to see a link to a quadrilateral flip book. Would not be a bad idea to take a look at that too. That is one of the activities we're going to be doing in class to help work on these conjectures. The last thing I want you to do, the diagonals of the rhombus form two angles at each vertex, and I want you to compare those two angles. So again, I'm not going to use patty paper because I don't have it available on this, but I am going to measure these angles. So I'm going to put it right there at the vertex, line up 0, and you'll see just under 20, maybe like 19 degrees. Now, I'll flip it around so we can measure the other angle, and you'll see just under 20. Again, probably about 19 degrees. So this diagonal splits that vertex angle in half, or that angle in half. And you'll see I can do the exact same thing here. That angle measures about 70 degrees. If I flip it over to here, right at 70 degrees. So the way we're typically going to word that is that the diagonals of a rhombus bisect the angles of the rhombus. And that's true for both both diagonals bisecting all of the angles. So that was something that was true for the vertex angles of kites, but for a rhombus, it's true for all of the angles. And then the final thing here is we would talk about squares. So there's just a reminder here that because rectangles and rhombuses are types of parallelograms, the things that we talked about yesterday are still true. The diagonals do bisect each other on both rectangles and rhombuses. The angles opposite of each other are congruent on both rectangles and rhombuses. The opposite sides are congruent, and the consecutive angles, the angles next to each other, are still supplementary. All of those are still true for these shapes. That's one of the hardest things for a lot of people to understand, is that just because we only came up with 2 new conjectures for rhombuses doesn't mean that the 4 we already had for parallelograms don't still work. They do. And then the final thing we're going to do here is a square. So again, I'd have people draw a square onto this grid. You can see my aspect ratio is not so great right here, but we're going to pretend our best. And then we're going to take a look. Which of those conjectures are true? We know it's a parallelogram, so these four are true, definitely. Do the diagonals bisect the angles? Well, let's draw in those diagonals and find out. Does it look like they bisect the angles? Definitely looks that way, right? Are the diagonals perpendicular to each other? Absolutely, they are perpendicular. And are they equal to each other? Yes, they are equal to each other. So when I ask you which properties are true of squares, the answer is going to be all of them. Every single property we've discussed for any quadrilateral at all is true for squares, 100% of the time. They are the most special of all parallelograms or all quadrilaterals. Now, one thing you'll also notice here is there's no extra that's true about the squares. It's just the things we've already talked about. We don't get anything special. Now, one thing we do know, though, is we can actually go through and find all of the angles now. So if you know these are 90-degree angles because it's a rectangle, and because it's a rhombus, it's divided in half. We've got 45s in each corner, 45, 45, 45, 45, and we've got 90s at each of the middle. So without any information.
B lunch students should now be back in our class.
Okay, if you're on B lunch, now you're back. So we know the angles without even having to know one of them with a rhombus or with a square. So just a couple of examples we can do here real quick. Go ahead and clear that off. So we've got a rectangle here, and we want to find the measures of these angles, X, Y, and Z. So a couple of things we have to know is that a rectangle has 90-degree angles. So right away, if this one is 22, I can do 90 minus 22 and find this one, and that would be 68. No, not 68. Yes, 68. Yes, 68. I can do math. 68. Now, that wasn't one of the ones we wanted to find, but because this is a rectangle, we've got a couple of things going for us. These pieces are the same. All of these pieces are the same because they're equal diagonals and they bisect each other. All of those pieces are the same. That makes all of these triangles isosceles. So if I have 68 here, I get 68 up here. And now I can use the triangle sum conjecture to find x. So I'll pull out a calculator and do some subtraction. 180 minus my 68 and minus my other 68 leaves me 44. So x is 44. And then I've got linear pairs here. I can take 180 minus 44, and z has to be 136. So there's your way to do that. Something very good to know about rectangles, though. All of these pieces are isosceles. Next up here, we have a rhombus. So a rhombus gives us some more information in the fact that we know that the diagonals are perpendicular and that they bisect the angles. So a couple of things we would know right away. X, because these diagonals are perpendicular, x has to equal 90. I'm just going to go ahead and write that in, I guess. Maybe. There we go, 90. In fact, they're all 90 all the way around. The next thing we might know is all parallelograms have diagonals that bisect each other. And so a rhombus is no different. If we've got 5 centimeters there, we also have to have 5 centimeters there. And now the part to find y. So one thing we would know here is since these diagonals bisect each other, we'd have 15 and 15. Well, this is a parallelogram, so the opposite angles are equal. This whole thing is 30, and since it's a rhombus and they bisect each other, we'd have 15 and 15. We'd have 90 here, it's perpendicular lines, and now we've got this triangle. So we'd pay 180 for the total minus 90 minus 15 should be 75. And so y is 75. So for your practice tonight, what you're going to be doing is 1 through 13 and 21. Now 1 through 13 are a little bit different. These are going to be always, 1 through 10 are a little bit different. These are always, sometimes, or never true. So your job is to decide, are they always true? Are they never true? Are they sometimes true? And it does ask you to use sketches or explanations to support your answer. So if you're saying the diagonals of a parallelogram are congruent, well, that's not the property of all parallelograms, but it is true for rectangles. And a rectangle is a type of parallelogram. So I would say something like sometimes. And for my explanation, I might say it's true for rectangles. So that's kind of what I'm looking for in something like that. Then, of course, you've got a few down at the bottom here that you've got to actually find the solutions for. So 11 is a rectangle, 12 is just some random parallelogram, and 13 is a square. Then I want you to try number 21. These first set, these 1 through 10, there are some questions like that on the quiz, and then most of what you're doing is like this. So I will post answers to this tomorrow, so make sure you've tried them first. And then come back tomorrow. We're going to be spending the entire next 2 days. So in class, that'll be Wednesday and Thursday, reviewing all of these properties. So if you're not in class doing those activities with us, you need to be spending probably around an hour and a half to 2 hours this week, the normal time you would have spent in class studying for this. It is very important that just because you are at home, you're not just blowing this off. The people in class are spending the entire next 2 days reviewing this. You need to do something similar. Okay? Let me know if you have questions, and I'll see you later.